Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at analytical geometry. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say it's massively Hey, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. Cindy, please make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So you guys did confirm that you are able to clearly see over there, isn't it? Elton, can you clearly see? Can you hear me?
Yes, sir.
Okay, 100%. So in today's lesson, what I'm going to be doing is to take you through revision, inclination of a line, equation of straight line, application involving quadrilateral. Obviously, most of you guys are able to notice everything over there. And one thing for sure, some of you guys are not seeing this for the first time. So just make sure that for every time when I move to the next part of the lesson, you guys understand everything. Otherwise, if there's something that is confusing, just make sure to interrupt, mention your name, and I will recognize you, honorable member. So now, quickly, I want to take you through revision where we will look at the distance, midpoint, and gradient formula. So we won't spend much of our time on that one. So what we'll be doing is just a quick revision. One thing for sure in this lesson, we've got grade 10s, grade 11, and grade 12 learners. So one thing for sure, what I'll be doing, it's not something that you are seeing for the first time. So as I've indicated, let's quickly try to have a look at the distance formula. So guys, what exactly is the distance formula? Remember, the word distance is one and the same thing as the length. So if you have a straight line, of which in real life, this straight line could be a road from your house to the clinic. So now, when we talk about the distance, we talk about the length from your house up to the clinic. So in case if we say this is kilometers, ladies and gentlemen, it simply means the length from your house to the clinic is 2 kilometers. So there are multiple ways in which we can determine the length from one point to another. Here's the formula, which says D is equals to the square root of into x2 minus x1 close squared plus y2 minus y1 squared. I want you guys to notice something. For this formula, for the distance formula, you can see that we've got the x coordinates and the y coordinates. In short, let me say we've got two coordinates. The x1, obviously the corresponding y value will be y1. We also have x2 and y2. What is this, ladies and gentlemen? This is what we call the coordinates. So always the coordinates has got the x and the corresponding y value. So the moment we say h, this h represents a point which could be a house in real life. For the second coordinates, there it's going to be C. So this C could represent a clinic in real life. So in high school, we are not that much interested in real life. It's just to introduce you to the way in which calculations are done. So I want you guys to be aware that in exam, at all times, for you to apply this formula, you must be having two coordinates. So for every question related to distance, just make sure that you've got two coordinates. If you don't have two coordinates, it means you might be having one. The other coordinates you might need to somehow calculate, of which is something that I'm going to take you through when we deal with exam type of questions. I'm not sure. Before I move to the next part of the question, or the next part of the lesson, is there someone who's got a question in relation to the distance formula? Or did that make sense to everyone?
It made sense.
Shreyas, are you happy there?
Yes.
Cindy, ujabulile lapho?
Yes, sir.
Okay,
Ngijabulile.
100%. So now, quickly, let's do a bit of a revision in relation to the midpoint formula. So let me also use the same example to say, this is your house, this is the clinic. So now, when we talk about the midpoint, you just know this formula being the midpoint. So this word on its own, mid, it's actually a short word of middle. So when we talk about the midpoint, we are actually talking about the middle point. So when something is in the middle, it has to be in the middle of two things. What are those things? In this case, we're talking about points. So that means the middle point, it is going to be a point which is in the middle of 2 points. In this case, we've got that point and we also have this point. So a point which is in the middle, it has to be right in the middle of the 2 points. Very, very much important, ladies and gentlemen, over there. It could be a spaza shop in real life. So that means if we want to know what are the coordinates of the midpoint between these 2 points, this is the formula that we use in that case. It says the middle point is actually the sum of 2 points, and you divide it by 2. Remember, the coordinates has got the x and the y value. So you add the x value of h with the x value of c, and then you divide that by 2. It therefore gives you the x value of the spaza shop. So you do the same for the y value. So you add the y value of your house, of which let's refer to that as y1. You add it with a y of the second point, of which you can refer to that as the y of the clinic, or otherwise this is going to be the y of your house. So just to be consistent, in this case, I'm using 0.1 and 0.2. So that means here we are going to add with the y of 0.2. It therefore gives you the y of the spaza shop. So in short, it's more like we're saying x of the midpoint is equals to x of the house plus x of the clinic. You divide that by 2, and when it comes to the y value, is y of the house plus y of the clinic, and you divide it by 2. So it is actually going to give you the value or the coordinates of the middle point. So that's all that you need to be aware of regarding the midpoint formula. Something very, very much important, ladies and gentlemen, which is almost common to the distance formula, is that also in this case, you need 2 points. Without you having 2 points, you cannot use that formula. You cannot use the distance formula. So what I like about these formulas is that you must at all times have 2 things, not necessarily 2 points, but 2 things. Why am I saying 2 things? It's because it's not at all times where the question might say calculate the distance. In some instances, they can give you the distance and 1 point and ask you to calculate for the other point. So it shouldn't be that. Since this is the midpoint formula, it means at all times examiner will ask you to calculate the midpoint. They might give you the midpoint and ask you to calculate the other coordinate. So in short, what I'm saying, Grace, is that you might be having a tree. So in class, they normally teach you on how to climb a tree. And when you get to exam, they make an assumption that you are at the top of that tree. And they say, now get to the ground. So if you only know how to climb a tree, it's going to become a bit of a challenge in exam for you to get off that tree. Very, very much important, ladies and gentlemen, that everything that you do, you have to do it in both directions and expect whichever question, because obviously you'll be aware of everything that is in relation to that particular question. So, do you guys allow me to move to the next part of our lesson? Is there someone who's got a question in relation to that?
No.
No, sir.
No, sir.
Season, are you okay that side? Amogelang.
So then what
Onkamogetse, are we okay that side? Elton?
Yes, sir.
Okay, 100%. So now I'm just going to quickly remove all of this. So remember, guys, all of this is what you should be aware of at grade 10. So now let's talk a little bit more about the gradient formula. So the gradient formula says change in y over change in x. Ladies and gentlemen, this weight, let me just say this sign or symbol, sometimes you can see it in physical sciences. It's a Greek weight. This thing is called delta. So this is a Greek word which simply means change in English. So what does change mean? Change mathematically, it means whatever 2 minus whatever 1. So if in this case we are saying change in y, so that means it's y2 minus y1. If I'm talking about L10 and I'm saying change in L10, ladies and gentlemen, because I've got that simple, it simply means L10 2 minus L10 1. It doesn't matter if you like a chicken, ladies and gentlemen. The moment is chicken attached to that, it simply means a chicken 2 minus chicken 1. So, good people, what I'm trying to explain is that the moment you see that, just ask yourself, what is this attached to? So can you see in that case, it is attached to y, which means the formula, when we expand it, is going to be y2 minus y1 over x2 minus x1. So always when you see that, you know you are dealing with a change. That is why when you go to the shop to buy something and you've got a change, the transaction is such that you give the shop owner, let's say, 10 rand, and then the shop owner gives you your change. Let's say they give you a, what is it, 2 rand. So if we want to calculate the change, it is going to be a, what is it, that being R2 minus that being R1. So change is actually the difference between the two values, which means also in this case, you must be knowing your Y2 and your Y1, your X2 and your X1. When we talk about the gradient in real life, we talk about the slope. Let's say this is you in Cape Town, you are walking, approaching Table Mountain. At some point, because it's a mountain, it does something similar to that. And then you've got that table of a mountain on the other side, it does something similar to that. So in real life, when we talk about the gradient, we are actually looking at how steep is that Table Mountain. Can you see from this point, for example, up to that point, if we draw a straight line, we therefore have an idea of the slope of that Table Mountain. It's more like we can determine how steep that mountain is by making use of this formula. So also, if you are driving up a hill and this is a road, it does something similar to that. We are therefore able to calculate to say a truck of this size, for example, it won't be able to climb that road. Why? Because maybe it is too steep. How do we know that this road it is too steep? Good people, this is the formula that we use. We are able to say this is higher from that point. Then we are able to determine that height using that formula. And also, we are able to determine that length from there to there being x. We therefore make use of that formula to tell that this road compared to that mountain, maybe the mountain is way too steeper than that road, but still as an individual, you cannot climb that mountain by walking because it's too steep. How do we know? This formula is going to tell us. Also, the same calculation may be performed for this truck to tell if it will be able to drive up to the top of that road. So, something also that you need to be aware of is that with the gradient formula, you also need to know two things for you to use that formula. So in short, the distance formula, the midpoint formula, and the gradient formula, three of these, you must know two things in order to apply these formulas. So what examiner does is to try and be tricky by giving you 1 point, for example, and then from there, somehow either give you the distance, the midpoint, or the gradient, and somehow ask you to calculate something. So just make sure, ladies and gentlemen, that you are aware that you need to remember all this information that I'm explaining. Very, very much important, ladies and gentlemen. So, guys, before I move to the next part of our lesson for today, is there someone who's got a question in relation to all that I've just explained now? Rato, I had to mute you from my side because I noticed your mic was unmuted. There was a bit of a background noise. So just in case if you have noticed, you can just raise your hand and I'll unmute you so that you can be able to participate. Sizeni, Amoelang, Lebohang, Yongama, Cindy, Tumza, Elton, Shreyas. Is everything good that side, or is there someone who's got a question?
No question, sir.
No question, sir.
Last one to confirm.
Sir, what about
Yebo.
the tan theta is equal to m? Does that count
Okay.
as a gradient formula?
Yes, it does, Mr. Elton. So, I think that will fall under the next part of our lesson. So, I'll just make an assumption that you did understand all of that. So now, as we continue with our lesson, we will now move on to this part of inclination of a line, of which what you have just said now will be clarified in that part of the lesson. So I'm just going to remove all of these, and then from there, I'll explain to you exactly what is meant by a line of inclination. But before I do that, you guys need to be aware of something. Is there someone who can tell what exactly is this thing?
Cartesian plane.
It is a Cartesian plane, sir.
Ladies and gentlemen, this is what we call a Cartesian plane. So you need to be aware that your Cartesian plane has got 4 quadrants. This is quadrant number 1, this is quadrant number 2, this is quadrant number 3, this is quadrant number 4. For someone who's in grade 10, you might hear us saying the word quadrant, but you might find that it doesn't make a perfect sense. So suppose you've got a ledombolo there. Shreyas, I'm not sure if you know what ledombolo is. I'm also not sure. What is ledombolo in English? Is it someone who can? Is it dumpling? Do you know what that is, Shreyas?
No, sir.
You don't know, ne? Hey,
Yes, sir, I don't know.
even if I say lekaku, one thing for sure you won't understand. But let's say it's just a round bread. Yeah, let's say it's a round bread. Or some Shreyas, let's say pizza. You know pizza, Moose?
Yes, sir.
Yes. So when we say quadrant, listen very carefully. Quadrant. Notice something about this word. There's a sound of quarter there, Shreyas. So a quarter, you know, if you've got a full loaf, this is half. That's when you cut it into half. So if you have another half, then this is quarter. If you have the other half, this is quarter. So that means you've got a 4 quarters. Quarter 1, quarter 2, quarter 3, quarter 4. Also, when it comes to the Cartesian plane, this pizza, you can cut it into half and then another half. Then can you see, this is quarter, which is what we call a quadrant number 1. So it's more like it is this. This is quarter number 2. It is that. This is quarter number 3. It is that. This is quarter number 4. It is that, ladies and gentlemen, because we come from good hands, we therefore don't just say this is a quarter, but we call it a quadrant. Very, very much important. So every time when I talk about a quadrant, I'm simply referring to a specific quarter of the Cartesian plane. So now a Cartesian plane has got the x-axis. What is the x-axis? It is this straight horizontal line. This is the vertical line called the y-axis. So I want you guys to be aware of something. Functions, which could be a straight line, a parabola, a hyperbola, or an exponential. Everything is drawn on a Cartesian plane. So especially when you guys are dealing with functions, don't be intimidated by the given diagram. Just know that functions are drawn on a Cartesian plane. So you should be able to notice your Cartesian plane having that and that. Then you know it's a Cartesian plane. The moment they draw that, then you know this is a straight line drawn on a Cartesian plane. So on my previous lessons, I used to say a Cartesian plane is more like a plate, Cindy. This is a plate. What do we normally use a plate for? Remember, I relate a plate to a Cartesian plane. So that means this is a plate, then this is a Cartesian plane, as an example. Cindy, I know very well that there in KZN, you guys chow a lot of putu. So this is your putu, Cindy. Can you see that without a plate, you cannot dish your putu? Similarly, without your Cartesian plane, you cannot have a function which could be a parabola. Also, it's not only putu that you guys chow. I know very well, Cindy, that yesterday you chowed putu and acha. So there is your acha. Where do we dish that acha, Cindy? We dish it on a plate. Ladies and gentlemen, we also have a straight line on that Cartesian plane. Very, very much important, ladies. It doesn't end there. You can still add some more food onto that plate, which is why you can also have some more functions on one Cartesian plane. So the reason why you guys fail the functions is also not being able to identify your Cartesian plane. So from now on, you guys need to be aware that a Cartesian plane is like a plate having functions which could be your putu, your acha, your whatever. Very, very much. So now on upcoming lessons, that's where I'm going to teach you what exactly is a straight line, what exactly is a hyperbola, a parabola, and a function. So that is why it is very, very much important, ladies and gentlemen, that you do not miss any of my upcoming lessons, because once you do, you'll only know that there's something called a plate, but you don't know what we dish inside a plate. So now, can you guys see? We've got a Cartesian plane, we've got point A, point B. This is just an example. Remember, guys, a point, it's a point for the coordinates. The coordinates, that's where you have X and Y. Very, very much important, ladies and gentlemen. So now, this could be point A having X and Y, point B having X and Y. So, just to spice things up, let me also add that line which could be C having the coordinates, D having the coordinates. So questions related to that under analytical geometry, examiner may ask you to determine the distance between point C, D. Remember, guys, the moment they say the distance, you must be having two things. Of which if is the distance that they want you to calculate, you have that point and that point. If they say the distance between point A and B, you must be having a point and a point with the coordinates. So the distance formula, it is going to tell you that from there all all the way up to there, it is this long, or whatever the length that may be. And also, if they say the midpoint between point C and D, so it's just a point between that and that, of which it can be estimated to be somewhere there, because it is a point which is between the 2 points. Also for AB, it could be a point somewhere there. So now for the gradient simply tells how steep is that line. So a line could be steep in that way, or otherwise it could be steeper, or it could be steeper than that, or it could be a. If it's not steep, what is it in English, guys? Can someone help? Hey, guys, are you like me who ran out of English data, guys? Elton, hey, free us, fill in the missing weight. You get it? If you don't get it,
Forget about it.
forget about it. So, ladies and gentlemen, you might be given lines in different slopes. So you just need to be aware that the gradient of a line, it tells how steep the line is. So I hope you guys are aware of all that I've explained over there. Otherwise, for those of you who heard that information for the first time, just make sure that you don't forget all of that. Remember, guys, this lesson is being recorded. You don't need to stress that much about having to write the notes. Otherwise, in case if there's something that I've explained and you'd like to revise, you can still catch up at a later stage. So now, let's talk about inclination of a line, well known as, let me say, well known to be associated with an angle of inclination. Remember, guys, we draw lines on a Cartesian plane. Very, very much important, ladies. So before you can do whatever, you must be having a Cartesian plane if you want to explain a straight line, a parabola, hyperbola, exponential, or whatever the function that you might want to explain. So it can be simply explained making use of a straight line drawn on a Cartesian plane. So when we talk about inclination of a line, listen very carefully, angle formed with the horizontal in an anticlockwise direction. For the last time, honorable members, listen very carefully. Angle formed with the horizontal in an anti-clockwise direction. Remember, guys, we've got direction which could be an anti-clockwise direction, or otherwise clockwise direction. Sometimes it could be confusing in terms of which one is which. But let's maybe start here to say a clock, and maybe associate a clock with a watch. So I'm not sure, guys. We call this thing managana. I'm just not sure what you guys are calling these things. Hey, antennas. Did you guys get that? Elton,
Sir?
did you hear that?
Yes.
Cindy. Okay.
Yes, sir, I heard that.
In which direction are these antennas moving? Are they not moving in this direction, guys? You know the watch is moving in this direction, isn't it? Yes. So what I wanted to explain, a clock or the antennas of a clock move in this direction. That is why it is a clockwise direction. So anti-opposite of whatever. So whatever in this case is clock. So that means anti-clockwise will be the opposite direction of clockwise, which means anti-clockwise, it is actually going to be in the opposing direction. So that is what we mean by anti-clockwise direction. Cartesian plane, if just draw that and say there we've got an angle called theta. Without me having an arrow there, or it might be easy to tell in which direction is that. But the moment I do this, then you know we've got an angle which from zero, and then now it is rotating in an anti-clockwise direction. So, Elton, this is now what we call an angle of inclination. So, this angle theta is called angle of inclination. So, because now we are talking about a line which is at a specific angle. So, this is the formula that you were talking about to say tan of angle theta, it is actually equals to the gradient. We might not know much about this, but we do know very well that the gradient, it is actually equals to change in y over change in x. What is change in y? Remember, the word change simply means delta, meaning y2 minus y1 over x2 minus x1. Very, very much important, ladies and gentlemen, over there. So now, I'm not sure, Elton, are you happy there regarding that formula?
Yes, sir.
And also, did all of you guys get that part of an angle of inclination?
Yes, sir.
Hey, Tumi, gano ka re o robetse ka mona. O hona?
Yes, sir.
Faith, Cindy, o sasekhona lapho.
Yebo, sengikhona.
Futhi uyazwisisa ukuthi ngithini lapho. Uyangithola noma
Yebo,
cha?
ngiyakuthola hle.
Okay, kwakuhle lokho. Manje, ho, almost continued in isiZulu, guys. So what I'm saying is, we might have two different types of lines. Let's say we've got this Cartesian plane being y and x. We might have a line in that direction, or otherwise we might also have a line in that direction. Very, very much important, ladies and gentlemen, over there. Something that you guys need to be aware of is that for a line with a gradient or a line that ends in quadrant number 1 and quadrant number 3, the gradient of this line is positive. And also, the gradient of this line ending in quadrant 2 and quadrant 4. This line has got a negative gradient. Some of you guys remember from the lesson that I did for functions. So that means all the straight lines in that direction are going to have positive gradients. All the lines in this direction are going to have negative gradients. You just need to be aware of that, ladies and gentlemen. Why am I telling you this? It's because when you use this formula, tan theta is equals to change in y over change in x. In some instances, you might have a positive value of an angle. And also, in some instances, you might have a negative value of the angle. Here comes a question. In which situation are you having a positive gradient? Not necessarily a positive gradient, but a positive angle. So that's if you have positive gradient or a line that ends in quadrant 1 and quadrant 3. Also, where you have a negative gradient or a negative angle, that's where you have a negative gradient. So now, the moment you get a negative value of that angle theta, just be careful of something. So that means your theta, it is going to be equals to 180 degrees minus whatever negative angle that you get. Remember, guys, everything that I'm saying now, you don't need to forcefully squeeze it inside your mind. Just be aware of everything that I'm saying. Everything is going to make perfect sense when we solve for exam type of question papers, of which in today's lesson, I'm not going to be solving any exam type of problems. But what I'm going to be doing is just to take you through the question papers, and then on our next lesson, we'll be solving for the questions. Very, very much important, ladies and gentlemen, that you fully understand all that I'm explaining in today's lesson. So I'm just not sure, is there someone who's got a question in relation to all that I've explained just now? Sizeni, are we doing okay that side?
Yes, sir.
Last one to confirm.
So, you said it'll be theta is equal to 180 degrees minus what?
So this is 180 minus whatever angle that you got. Maybe let's try to quickly do an example. Okay, let me quickly try to do an example. I hope this example actually answers the question. Let's say this is point A. Obviously, the x value is negative, so it could be negative 2. We have a y a positive, the let's say is 4. And then this is point B. Let's say the x value obviously is positive on this side, maybe it's 6. The y value, let's say it's negative 4. So now, if you want to calculate the remember, the angle formed, it is this angle of inclination. This is that angle theta. So that means the angle starts from the positive side of the x-axis and then you draw it up until it touches that straight line. So let's see. That means the gradient, or otherwise you can represent the gradient as just a small letter m. We know that is y2 minus y1 over x2 minus x1. What is y2? Maybe let's take this as y2. So y2, it is going to be -4 minus y1. What will y1 be? Obviously, positive 4 over there. All over x2, obviously, it is going to be minus what is x1? Obviously, so it is going to be that. I think got negative. What is not negative? What is this? This is that, I think 8 positive. So what is this over that? Is it not -1? So can you guys see that end of line A, B, it is a negative gradient, which means calculate the angle for here tan angle being equals to 1 because the gradient is equal to -1. So for you to calculate that, you need to do the same function of r, which means that it is going to be a function of negative. This when you punch a negative value. What are you guys getting there?
It's -45.
Let me quickly do it on my side also. Let's see. What we have in shift turn. Yes, we are getting -45. I want you guys to pay attention to this. Very, very much important, ladies and gentlemen. So this -45, what angle is it? The negative, it gives you this angle. So that means this angle is -45 degrees L10. But we are not calculating for this angle. We actually want this one. That is why we are therefore going to say a angle theta, it is actually equals to 180 degrees minus 45 degrees. This is equals to what is that? Another 45. What is this?
135.
135 degrees. So can you guys see that this angle is bigger than that one? So there's no way this can be that 45. So that is why we say 180 minus whatever angle that you got. So that means the angle theta is equals to 135 degrees. So that means it is always where you have a negative gradient, you will always have a negative angle, of which you must say 180 minus that angle, and then you get a bigger number. So this bigger number, it is that angle. But if you had something similar to this L10, you were going to have a positive gradient, and therefore you are going to have a positive angle theta, and that positive angle theta would be that one. Very, very much important, ladies and gentlemen, over there. I'm not sure. Elton, are you happy there? Is everyone happy
Yes, sir.
based on what I've
Yes, sir.
explained over there? Yongama siyo, Faith, Cindy, lijabulile lapho.
Yebo,
No, we're
sengijabulile.
happy.
Okay, 100%. So remember, guys, you don't need to stress that much about all that I'm explaining to you now. But what matters the most is that you be aware of everything that I'm talking about now. Coming next week, I'm telling you guys we'll be doing some exam type of question papers, of which I'll take you through those just now. So I'm not sure. I think we can now move to the last part of our lesson for today. Not necessarily the last, but we can do these, and then from there, we just discuss the question papers which were sent in the group. So now, let me quickly take you through equation of a straight line. So remember, guys, whatever that we are dealing with, if it has a formula, let's write it down. We do know very well that this is the general formula for a straight line, being y is equals to mx plus c. Very, very much important, ladies and gentlemen, over there. So now, with the formula of a straight line looking similar to that, let's try to unpack all of that. So obviously, we know that a straight line is drawn on a Cartesian plane. So this y, it talks about the value of that y. This x, it talks about the value of that x. We have learned in the beginning of this lesson that m is the gradient, and it has a formula being changing y over changing x, being y2 minus what is it, y1 over x2 minus x1. So now this c, Shreyas, if you remember, we said the c value on a straight line influences the vertical shift. So that means originally a straight line was just a simple thing similar to that, being just y is equals to, obviously it's going to be positive mx. But the moment we shift this function, let's say by 2 units upwards, so that means we'll shift it from that 0.2 by 1, 2, meaning it is now going to be cutting through that point. So this is therefore going to be y is equals to positive mx plus 2. If it's negative 2, it means it has been shifted downwards by 2 units. Negative means down, positive means up. So that means the C value on a straight line tells us more about the vertical shift. So if maybe we have something similar to that, and let's say this one, it passes at negative 3. So that means this is the one for y, it's equals to, it is going to be negative mx minus, it shifted by 3 units downwards. So the gradient, it tells us more about how steep is that. How steep is that? As long as it passes through the same point, it means what changes is actually the gradient. Maybe it could be 2 for that line, it could be 4 for this one, it could be 1 over 2 for the other line. But remember, it is a negative gradient because it is a line that ends in quadrant 2 and also in quadrant 4. Very, very much important, ladies and gentlemen, over there. So now, that means for you to determine an equation of a straight line, you need 2 things. Normally, what you need is the points. How many points do you need? You need 2 points. Very, very much important, ladies and gentlemen, over there. So with the 2 points having 2 coordinates, you can therefore easily calculate the gradient and use 1 point. It could be that point or otherwise that point in order to calculate the C value. Very, very much important, ladies and gentlemen, over there. So that means it is not at all times where you might be given 2 points. Cindy, sometimes examiner can try to be clever and give you 1 point and again gradient. As long as you have this information, 1 point and gradient, you can substitute the gradient there and then use this 1 point to calculate the C value. If examiner does not give you a point and a gradient, they will give you 2 points. And then with the 2 points, you can calculate that and then use just 1 point to calculate that. I hope that makes perfect sense to everyone. So, lastly, in addition to this, I want you guys to be aware of something. The lines. I'm sure you guys do know very well that lines can either be parallel, let's say straight lines, especially under this chapter of analytical geometry. We can have 2 parallel lines or 2 lines being perpendicular to each other. I think we do know very well that for lines which are parallel, they have the same gradient. So let's say, for example, this is line 1, this is line 2. So that means the gradient of line 1 is equals to the gradient of line 2. It's not always 2 vertical lines. On a Cartesian plane, you can have lines in that direction or otherwise lines in that direction. If these 2 lines are parallel to each other, simply means the slope or the gradient is the same or equal. So when it comes to lines which are perpendicular to each other, what makes them to be perpendicular is them forming a 90-degree angle over there, which means, for example, this line and that line could be perpendicular in the sense that they form a 90-degree angle over there. How do you know if a line forms a 90-degree angle? That's if they draw that 90-degree sign, or otherwise in the statement it is mentioned that those are the perpendicular lines. Very, very much important, ladies and gentlemen, over there. So, guys, please make sure that you pay full attention to all the details. So, when it comes to perpendicular lines, is different from what we are having over there under parallel lines. So we say line 1, which could be that one, that vertical one being line 1. When you multiply it with line 2, not just the line, but the gradient of line 1 multiplied by the gradient of line 2, they must give you -1. So this is a formula, ladies and gentlemen. This is a formula that you always need to be aware of. And lastly, this is not only how we may represent an equation of a straight line. Some of you guys at your school, they might teach you in this way, where they say y minus y1, it's equals to m into x minus x1 and then close. Very, very much important, ladies and gentlemen, over there. So I'm not sure, guys, is there someone who's got a question in relation to all of that, or did you guys understand over there?
Understand.
Guys, are you still there?
Sir.
Last one to confirm.
Question, sir.
No question. Okay. So let me maybe bring this question which was sent in the group. I'm just going to quickly explain something there, just to make you aware that everything that we've covered in today's lesson, it might be useful when it comes to us answering this question. So let's see. See a point on the x-axis. There is a point being C. A having -5 and -3. There is A. There is a point. And B are the vertices of a triangle. There is B. So can you see a triangle has got a point, and a point? 3 points. 1, 2, 3 sides. Angle there, angle there, angle there. So we also have some angles over there. So now they say AB intersects the x-axis at E. Where's AB? There's AB. It intersects the x-axis at E. Yes, I agree. In triangle ABC, angle B is equals to theta. In triangle ABC, angle B is equals to theta. Yes. In triangle BEC, angle E is equals to alpha. So they're saying in triangle BEC, that angle E is equals to alpha. Yes, I agree. So already, can you guys see that this alpha is actually an angle of inclination? So let's quickly try to have a look at the questions and just have a discussion. Remember, guys, I'm not going to be solving any question, but on our upcoming lessons, that's when we'll be solving for these questions. So can you guys see that 4.1 says calculate the gradient of AB. This question is allocated 2 marks. So as I've said, you must always have two things if you want to calculate either the gradient, the distance, or the midpoint. So do we have 2 points? Yes, we do. There's point A, there's point B. You just substitute into the formula, and then that's how you calculate the gradient of AB. Score yourself 2 marks. 4.2, determine the coordinates of point E. Very, very much important, ladies and gentlemen, over there. So now, this is where you need to be smart, guys. You can derive an answer based on the information that I've given to you. Because maybe we know that the gradient of that, we already know it, obviously. You can still find the equation of that line, and then from there, after determining an equation of that line, then you use maybe whatever information that you know about E to determine the coordinates of E. Because already we know that at point E, something is 0. We don't know what is X, but we know that Y is 0. So if we know equation of that straight line, we can maybe use that equation to calculate X, because we already know that at point E, Y is 0, something like that. And also for point E, expect to find a negative X value, because point E is on the negative side of the Cartesian plane, or the negative side of the X axis. Very, very much important, ladies and gentlemen, over there. So now, Mr. Elton, LT 4.3, determine the size of alpha, round off to the nearest whole number. What is alpha? Can you guys see that? Alpha is our angle of inclination. So we do know the formula, as Elton said over there. We say the formula is tan theta is equals to the gradient. We already know the gradient of that line. So that gradient, which you calculated at 4.1, you can just equate it to tan theta and get the second function of tan theta. It is going to give you an angle, which is possibly in the form of a decimal. And here, instruction says round to the nearest whole number. If you get maybe 10.7, round it off and write it as 11. If you get 10.1, you know you can't round off 1, then you just leave it as 10. Don't write it as a decimal as your final answer. Very, very much important, ladies and gentlemen, over there. 4.4, if theta is equals to a 76, determine the equation of the line through A through A parallel to BC. Parallel to BC. So you have that angle, and they say a line being parallel to that line over there. So I'm just not sure, guys, but according to me, the moment they give you an angle, maybe with that angle, you might do something of which somehow you can be able to calculate, let's say, the gradient of which, let's say, if we know the gradient of that line, then the gradient of this line, we can equate it to the gradient of that line which passes through A and also parallel to that line, and then use point A to determine an equation of that straight line. So remember, the moment the question says determine equation of a straight line, just write y is equals to mx plus c. Then you know you firstly need to battle with getting the gradient. After getting the gradient, you just use that point to calculate the C value. After getting the C value, you know you can rewrite equation of a straight line. So you can see it's given 5 marks, which means you might need to think deep for question. Very, very much important, ladies and gentlemen, that when it comes to this type of questions, you pay full attention. Very, very much important, ladies and gentlemen, over there. So now I'm not sure, guys, if all of you guys did understand all that I've explained in relation to this question. Did it make sense, guys?
Yes, sir.
Yes, sir.
Last one to confirm.
Sir, may you please redo 4.2?
You mean to explain 4.2?
Yes, sir.
Let's see. Okay, so maybe this will be our closing. Let me quickly try to redraw that and say we've got that. This is just a sketch. This is y, this is x. We know we've got b. We know we've got a. Then we've got that. Then we have point E there. I'm sure Cindy, you agree that we can simply calculate the gradient of that line. Let's say maybe the gradient of that line is 2. It's an example by using these 2 coordinates. So that means we therefore have y is equals to 2x plus c. Then we can use one point, either the point or this point. But I would use this point because it has positive values. This is 4, this is 12. This is -5, this is 3. So negatives, I might make some mistakes, so I can use that one. Let's say maybe I use this one to calculate C, and maybe it ends up being y is equals to, let's say 2x, and then let's say plus 3. So let's say we now have an equation of a straight line of that, even though it is not asked in the question that determine an equation of that. But because you know that if you have this equation, you can easily calculate that point. What do we know about that point? We know that at point E, what is it? Y is 0. We don't know what x is. Did I say what x is? Hey, whatever, guys. So now, Cindy, we know that y is 0. Why not substitute it there and then try to calculate x? So that means it is going to be 0 is equals to 2x. Let's say plus 3. You take it to the other side, it's negative 3. And then you divide by 2. Whatever that you do on the other side. So that means x is actually equals to negative 3 over 2. So it's more like it's negative 1, 5. So that means here, this point is actually negative 1, 5 or negative that. So somehow, Elton, examiner was smart enough by not saying determine an equation, but indirectly they knew that for you to determine, you must firstly determine the equation of a straight line of that line and use that equation to determine that point over there. I'm not sure, guys. Cindy, ujabulile lapho? Uyangithola?
Ngiyakuthola, ngiphendulekile.
Uphendulekile. Okay. Has everyone been pendulelked? Amogelang?
Yes, sir.
Uphendulelekile lapho? Yongama, are we happy there? Gracie, usasekhona lapho? Noma
Yebo, sir.
ubalekile? Okay, ladies and gentlemen, this brings us to the end of our lesson for today. I hope you guys did enjoy today's lesson. So guys, thanks very much for joining. My name is Desmond, and I'm out.